All right, here, example 5, we're graphing cube root functions. So if you need a refresher on cube roots, you can watch the intro on the cube root function. But here we know our domain is all real numbers. But again, we want to find that central point first. So we know what can go, we want 0 on the inside, so x would just equal 0. So that would be our central x, right? And then we want our y. Is anything being added to it at the end? It's not, so that means our y is 0. So we start at our central point here, 0, 0. And now what's different about this, we know, again, our range is all real numbers and our domain is all real numbers, right? So here, this 1/3, this dilation of 1/3, the a out in front, I know since that's positive that my graph is going to go up like that, and then it'll also come down like that. So if you need more than 1 point, I could plug in like a number, say like well, a number like 1, right? Because I know the cube root of 1. You might not be able to see that. Cube root of 1, that is 1, right? So I can plug in 1, that'd be good one. I get 1/3. So if I go 1, then I would get like 1/3. So I would say that was 1/3, right? And then down here, -1, cube root of -1 is just -1 times my 1/3 would be a -1/3. So -1, -1/3, right? And then I can draw it. It's going to look something like that. Here again, the next one, I set in what makes this 0. That'd be x equals -5, correct? So it means I know my x is going to be at -5, 1, 2, 3, 4, 5. And then again, I have no y out here, nothing being added to it on the outside, so I know it's 0. So my y is equal to 0. And then again, my a is positive, right? +1, so I have no dilation, I have no reflection. So my graph is going to go up from there and then rotate 180 degrees about the origin. And it looks like that, right? Again, you could plug in different numbers. You want to know the cube root. So I know the cube root of 8 is 2, right? So then I could plug in a 3 here, and I would get 2 out, right? So I could plug in 3, 1, 2, 3, and I'd get a 2 out, right? 1, 2. Okay, and then I could plug in to get a -8. I'd get cube root of -8 is -2. So I could plug in what? -5, and then -8 more, negative like 13, right? So if I plug in -13, I would also get -2 out. Okay, all right, last one down here. Now this one's a little bit backwards. Notice we have a -x in there. That's going to be a reflection about the y-axis. So it's going to flip these graphs about the y-axis instead of the x-axis when we have a negative in front of here. Okay. All right. So again, we said that what's inside the root equal to 0. And notice that this one, I would add x to both sides to get x equals 4. Okay. And then I have a +1 out here, so that's my y value. Oops. A +1, so I graph that. So that 1, 2, 3, 4, and then a +1. So normally I would go this way, right? But because that negative inside here is actually going to reflect it about the y-axis, so actually 1, 2, 3, 4, and then it's actually going to go this way and then down this way. And you could test that out by plugging in numbers, right? So I could plug in, say, to get a -1, or to get a 1. If I plug in 3, I would get the cube root of 1, which equals 1, and 1 + 1 is 2. So I plug in 3, I'd get 2. 1, 2, 3, 1, 2. There's a point right there. So you notice that it went this way. And then I could plug in a 5, right? If I plugged in 5, I would get -1. Cube root of -1 equals -1. -1 + 1 is 0. So at 5, oh, I didn't go up 1. I'm sorry. That stinks. You're probably wondering that the whole time I was doing that problem. So I went over 4, 1, 2, 3, 4, but I need to go up 1, right? Boom. And now it goes like this. So now if I go over 3, I'm up at 2. And then if I go at 5, I'm at 0. So it looks something like that. I could probably draw that better. Sorry about that. All right, that's why sometimes you do want to plug in numbers to fix your mistakes. All right, there you go.